Here's your review on rate graphs and the fundamental theorem of calculus, part 2. So first, a rate graph. If you want to, you could draw this, press pause and draw it, and then join in. So I'm just going to say that this story is about a tortoise that's traveling after noon. So like how fast, and this tells you the velocity, which is a rate, and this tells me time here on the bottom. If I ask some questions like, what was the tortoise's, and I have a tortoise at home, so I kind of like tortoises. What was the tortoise's velocity at 3 p.m.? You would then just look off the graph, 3 p.m., and it's 30 meters per hour. Tortoises are faster than you think, just so you know. Let's see, what's another question? They could ask for acceleration. What is the acceleration at 4 p.m.? Well, at 4 p.m. here, if I go to the graph, it's in the middle of a line, and this is what's important to recognize. Acceleration is the derivative of velocity. So off a graph, derivative means slope. So what's the slope of this line? How many down and how many to the right? I can see I'm going down 30 and to the right 2. So that's negative 30 over 2. And I know I can simplify that to negative 15, and then the units would be miles per hour, or, meters per hour, or meters per hour squared. So it's important to know how to write acceleration compared to velocity. If I ask you to integrate here from 0 to 5, the velocity, what I'm asking for here is to find the area. So if I look here, sometimes you can break it into two groups. So let's say break it into two, and I see, oh, here's a rectangle, and here's a triangle, and then I can find each area and add them up. So the rectangle is 3 by 30, so I go 3 times 30, and then the triangle is half the base, which is 2, times the height. So the base is 2, and the height is 30, and then I would add this up. So that's 90 and 30, and that's 120. Then here's the big question. Write a sentence, right? Saying, what does that mean? So what does this mean when you write a sentence in terms of, we found the answer to be 120. What does that mean in the context of the story? So you would write from noon to 5 p.m. The tortoise traveled, a total of, and it would be 120 meters. And it's really important, that is not a rate. So when you integrate a rate, it's no longer a rate. It tells you the total of whatever the unit is, and our unit's meters. So it tells you the total of how many meters. So how many meters did the tortoise travel? And the answer is 120. So I hope that helps just a little bit. Now the other part is the fundamental theorem of calculus. This means the derivative So the derivative and the integration undo each other. And what this does is creates a substitution question. So you take the top and you substitute in. So take out the x and put in, take out the t and put in x. And then the derivative of x would give you a hook. In this case, it's 1. And then you subtract. When you plug in 3 and take the derivative, the answer is 0. And that's your answer. Sometimes you got to be careful what order it goes in. So if the number is on top, so if the number's on top, and you do this, remember you have to see both derivative and integration, and you plug in the number on top, the answer is 0, and subtract, that becomes important. When you subtract 0 at the end, it's not important. But here, at the beginning, 0 subtracted is important. Then do your substitution, so take out the t and put in negative x squared. Take out the t and put in negative x squared. And then this creates a hook. So the derivative of this we can't forget. So that's negative 2x. And there's your answer. Let's try one more and then you got this. So we have a derivative. We're integrating. Let's say I have variables in both spots. I have something to do with t here. And then write it down. And how would this look? So the derivative integration cross out. So we're going to substitute x cubed in for t. And then the derivative of that creates a hook. Subtract. And now I'm going to plug in 5x for t. And again, the derivative of that creates a hook, and you did it. All right, that's the fundamental theorem of calculus where derivatives and integration undo each other. It creates a substitution question where the limits create the hook that you take the derivative at the end. All right, Mr. G Math, over and out. I hope that helped.